questions, all questions on functions of a real variable. So if you had followed the previous classes we had, you will notice that we had gotten to a certain extent where we could say we've actually done something. In this class, we are going to be solving problems on functions of a real variable from the beginning to the end. As many questions as we can take. So if you haven't subscribed to the channel, please subscribe to the channel, smash a like on the video, endeavor to put on your notification bell so that you will get notified whenever we go live or drop a new video. But in today's class, please take note, if you are joining the live class now, smash a like on the video. We are beginning our Q&A series, our question and answer series on functions of a real variable. So let's begin quickly with solving questions on functions of a real variable. Now please take note, after this class, just in case you couldn't understand one thing or the other that was done simply because you never attended the class or the classes we had previously, please go back to the link in the description and check out the videos we had, all the live classes we had on functions of a real variable. If we can go so far tonight solving problems on functions of a real variable, then it means we should be beginning a new topic tomorrow in tomorrow's live class. We might be going into differentiation, that is taking derivatives of functions. So please let us begin. Smash a like on the video. Let's begin. Now, I'm going to start with the very first question. Okay, so I'm going to be writing my questions here, and after solving them, we will go into the next question. So, question number 1 says, which of the following represents mappings? Which of the following represents mappings? So I'm going to put here, I have a set of relations here. So I'm going to put them A, B, C, M, P, and R. And we have here this, and we have this. So that's the first relation. The second relation we have is the next figure. So in the next figure we have P, G, O, or Q rather, and we have here Q, R, S. We have A, B, C, and D, and we now have this. Okay, we have the arrows going from Q to A and to D, and we have another arrow going from S to C and R to B. We have finally in C, or the second and last in C, we have A going to B under a mapping L or relation L, and we have this. So we have F, we have G, we have H, and we have E. Okay? So we have X, Y, and Z. I hope the camera can actually capture this. So we have G going into Z, G and F going into Z, and we have E going into X. Okay, so that's what we have. And finally, we have the last one will be, we have D. Another relation in D, this relation, we have this, R to S, under the relation H, we have A, B, and C, and we have this P, all of them going to P. So, guys, let's begin with this problem. So this is question number 1 we'll be taking in our Q&A series. So remember, if you are just joining this class is all about solving problems in functions of a real variable. Go back to our videos we made, all the live classes we had previously on functions of a real variable to understand all the things we discussed. Today we are going to be applying them, all the things we've learned so far in solving problems on functions of a real variable. Please, this class is an interactive class, so if you have questions based on anything being solved on the board, do well to drop your comment in the comment section. Let us see your questions. So this is not a church, this is not a mosque, this is not a social gathering or a place where people talk and you can't interact, this is a place where we talk, we interact, and we solve problems together. So we are solving problems on functions of a real variable. So now, question number 1 says, which of the following relations A, B, C, and D represents mappings? Okay? Which of them represents mappings? Now, I'm going to be answering the question. If you have a pen and a paper, please take note of the answers and why they are so. So it is important not only to answer the question, it is also important to take note of the reasons why the answers are correct. So let us look at the first mapping or the first relation. So the first relation, take note, is a relation F. Okay? Now, guys, if you go back to the videos we made, on functions of a real variable where we discussed mappings, you will come to realize that a mapping or a relation is only a mapping if it satisfies 2 conditions. Condition number 1 for a relation to be a mapping, please remember, is that every element in the domain of that relation must have an image in the codomain. That is condition number 1 for a relation to be a mapping. Condition number 2 is that every image must be unique, and the uniqueness of an image under a relation simply means that 2 images cannot be owned by more or by one element in the domain. Okay, so one element in the domain cannot have more than 1 image. So that is what the uniqueness property states. So we are going to be examining these particular relations, the 4 of them given to us, to know which of the relation is a mapping using those 2 conditions. So let's start with number 1. Now, under number 1, you will notice that there is a relation F that takes an element from X and assigns to that element an element from Y. Now, looking at this relation, let's examine if it is a mapping. Now, does it fulfill condition number 1? Yes, it does. It does fulfill condition number 1 because condition number 1 requires that every element in the domain must have an image. Now, ask yourself the question, does A have an image? Yes, it has an image. The image of A is P. Does B have an image? Yes, it does. What is the image of B? It is also P. Does C have an image? Yes, it does. What is the image of C? It is M. Now, it means that F has satisfied condition number 1, that every element in the domain must have an image, and that image must be a unique image from the codomain. Now, let us go to property 2, or condition number 2, for a relation to be a mapping. Looking at the codomain, let's go over to the codomain. If you go to the codomain, you will find in the codomain M, P, and R. Now, are the images out of M, P, and R, you will notice that R is not an image, but M and P are images. Every element of the codomain must not be an image. Take note. So, if M and P are images, let us examine them whether they are unique. If they are unique, uniqueness means that they cannot be paired with one image here, cannot be paired to more than one element of the domain. So looking at M and P, you will notice that they are unique. Since this relation F satisfies the 2 conditions, uniqueness for number 2 and all the elements in A, or all the elements in the domain having images, then it means that F is a relation. So I'm going to write here quickly, I'm going to write here that F is a mapping. So F is a mapping because it satisfies those 2 conditions. Condition number 1, that every element in the domain has an image. Condition number 2, every image is unique. Now, let's go to B. What will be the answer or your answer to B? Let's see, is this relation G a mapping? Now, if we want to examine G, whether or not it is a mapping, look at all the elements, you will notice that G, the relation G satisfies condition number 1. How does it satisfy condition number 1? Every element in the mapping or in the domain P has an image. But even as it satisfies condition number 1, you will notice that it has failed condition number 2. What is condition number 2? Condition number 2 requires that one element in the domain cannot have more than one image. But you will notice that whereas R has one image, S has one image, you will notice that Q, an element in the domain, is having more than one image. And that means that the uniqueness property has failed. Once the uniqueness property, what is one out of two properties or conditions for a relation to be a mapping, fails, it means that that relation is just a mere relation, it is not a mapping. So based on that, although the relation G satisfies condition number 1, it has failed condition number 2. So what would be our conclusion? We would conclude that G is not a mapping. So G is not a mapping because it has failed condition number 2, uniqueness property. Let's go over to C. If you go over to C, there is a relation L that takes an element in A, the domain, and assigns to that element in A unique element from the codomain B. Now, the question is this, guys. Is L, this relation L, a mapping? Again, we have to examine the two conditions. Let's check condition number 1, guys. Condition number 1 requires every element in the domain to have an image. You will notice that this relation F has failed condition number 1. Why has it failed condition number 1, or how has it failed condition number 1, guys? It has failed condition number 1 because F, G, and E in the domain, they all have images in the codomain. But you will notice that there is an element there in the domain H that has no image. So since there is one element, at least one element in the domain that has no image, it means that condition number 1 has failed. Condition number 1 requires every element, not some, every element of the domain to have an image. And in this case, you will notice that one element in the domain has failed the condition. It does not have an image. And what is that element, guys? The element in the domain that has failed that condition is H. It has no image. Now, if you go further to examine the second condition, that is condition number 2, you will notice that condition number 2 in this case is fulfilled because no image is no element in the domain has more than one image. Okay, so provided one condition has failed, it means that this relation is not a mapping. What is the reason for this relation not being a mapping? It is simply because L, the relation L, has failed condition number 1. H, an element in A, the domain, is not an element that has an image, whereas every element must have an image in the domain. So what do we conclude, guys? We are going to conclude for this mapping L, we say L is not a mapping. So please, if you have a pen and paper, take note of the reasons, okay? These are coming from what we have learned so far. Let's go to question number D, 1D. Now, let us examine this relation H, guys. Why is this relation H a mapping or not a mapping is what we want to see. Now, notice that there is a relation H that takes an element from A and assigns to that element a unique element from the codomain S. Now, let us see. The question is this, guys. Is H a relation or a mere relation or a mapping? Let us see. You will notice that H satisfies, the relation H satisfies condition number 1. What is condition number 1, guys, for a relation to be a mapping? Every element in the domain must have a unique image in the codomain. Every element. Now, you will notice that A, B, and C all have unique images in the codomain. So, condition number 1 is fulfilled. If you go over to condition number 2, you will notice that the image is unique. Why is the image unique? It is because no element in this domain has more than one image. A has one image P, B has one image P, C has one image P. All of them have one images, or one image rather, P. Okay? So it means that H, since it fulfills the two conditions, is a mapping. So what do we conclude? We are going to say H is a mapping. Okay? So guys, that answers question number 1. Now, you can ask a question right now, and I will go back again to explaining what we've done. However, if you want us to make progress to go on to question number 2, we have to move forward. Let's check out question number 2. So let's go back to question number 2. So that was for question number 1. After the class, you can go over the video again to check out carefully, probably in slow-mo, what we did. Let's see question number 2 now. Okay? I hope you can see this clearly. So let's see question number 2. Now, what does question number 2 say, guys? Let's see question number 2. Now, we have treated question number 1. Let's go to question number 2. Question number 2 says, determine the domain D, capital D, of the mapping. Determine the domain, capital D, of the mapping f from x, f of x equals 2x minus 3, comma, if C equals minus 3, minus 1, and 5 is the range and F is defined on D, the domain. Okay? So guys, this is question number 2. Let me read it out loud. It says, determine the domain D. There is a domain D of the mapping f of x equals 2x minus 3 if C is the range. Now, do you remember what we said about the range in our previous class? Guys, what is the range of a mapping? The range of a mapping simply refers to the set, a set containing all the images of that mapping. So the range is the set of all images of the mapping. Now, we are told that the set of all images is called C, and C contains minus 3, minus 1, and 5. So since C contains minus 3, minus 1, and 5, the range, we are asked to do this. We are asked to determine what the domain will be. So I'm going to be showing you, just in case questions like that will come up in your exam or in an assessment, how to go about solving it. So let's see the solution to this problem. So I'm going to put here solution and then go over to the steps you have to take. So the first step you will have to take, guys, for a problem like this is write out this. F from x to 2x minus 3 can be written, is equivalent. If you don't want to write it in this manner, guys, it is simply written as f of x. This expression is another way of writing f of x equals 2x minus 3. So in your exam, please don't get confused. All you have to do, if given this expression, re-express it as this. Both this and this refer to the same thing, okay? So the first step I would take if I were to solve this problem in an exam condition or an assessment condition will be to write it out like this, okay? Now, you could use a diagram to help you understand what is going on. In this case, I'm going to use a diagram just to show you what is actually going on. So there is a relation F, okay, that takes elements from a set D called the domain by what has been shown, okay? So there's a relation that takes elements from D, the domain, and assigns those elements in the domain unique images in the codomain, okay? So the codomain is called C in this case. What are the codomain in this case C is the range. Okay, so let's call the codomain something else. Since C is the range, I'm going to call the codomain E. Okay, now you will notice, if you remember what we had said earlier on in my class, you will notice that the range I told you is a subset. The range is a subset of the codomain. So if we call our codomain E, this range that we have been provided is a subset of E. So let's put this element, since C is a subset of E, let us put -3, -1, and 5. Let us put them into that codomain. Now, what they want us to find is x1, x2, and x3. Okay? Notice that x1 must have given -3 through this function f, meaning that this -3 can be called, this -3 you can call it f of x1. Okay? Now, please take note, this class is not all about solving problems. I'm not standing here to just keep solving problems. No, I am using the problems to teach you what to do. So we will be patient with it. Okay? We'll be patient with the process. The essence of solving these problems is to teach you how to handle problems, how to interpret problems. Okay? So I will look at this and call it f of x2. So and I'll call the last one f of x3. Now the problem here is, if we must know or determine the domain, it means determining the domain means finding out what the value of x1 will be, finding out what the value of x2 will be, finding out what the value of x3 will be. So please bring the camera over here. So this is what we are going to be doing now. I'm going to come over here. So let's look at what is f of x1. Okay? So if f of x, guys, we now know is 2x minus 3. F of x1 will be equal to 2x1 minus 3. Okay? So what was your f of x1? F of x1, your f of x1 is what? What is your f of x1? It is -3. So come over here, you will put in place of f of x1 -3, and this will be 2x1 minus 3. You then solve. So once you know that f of x1 is -3, -3 will be equal to 2x1 minus 3. So what will x1 be? x1 will now be, this 2x1 will be equal to, -3, this one here, and when this one comes over, it becomes +3. So 2x1 will be equal to 0, because -3 plus 3 gives you 0, and x1 will be 0 divided by 2, implying that x1 is equal to 0. Now, what have we done? We have now known that in the domain there is an element x1 that gave rise to f of x1, and that element is 0. You will now go over to f of x2. F of x2 would establish the relationship 2x2 minus 3. Now, what is f of x2? What is f of x2? F of x2 is -1. So since f of x2 is -1, come over here. F of x2 is -1. I'm going to put -1 is equal to 2x2 minus 3. And that would imply that 2x2 will be equal to -1 plus 3. And that means having this will give me 2. -1 plus 3 is equal to 2. So x2, 2x2 will be equal to 2, implying that x2 will be equal to 2 over 2, which is equal to 1. So you now have determined another element of the domain, and the next element of the domain is 1. Okay? Finally, if you now go over to f of x3, f of x3, if you go through what we have done, can be written as 2x3 minus 3, and f of x3 is 5. So if f of x3 is 5, it means that 5 will be equal to 2x3 minus 3, and 2x3 will now be equal to 5 plus 3, implying that if you make x3 the subject of formula, 5 plus 3 is 8, and this will be 8 over 2, and 8 over 2 is 4. So guys, you will notice that this can now be written, I hope they can see this.
Yes.
So this can now be written as 4. Now that we have determined x1, x2, and x3 being the members of the domain, what will we now conclude? You will now conclude, therefore, the domain D is a set that contains the elements 0, 1, and 4. And that answers the question. Okay? This answers the question. So when the question says, determine the domain of the mapping this, if the range is given by C equals this, then all you have to do is follow this procedure. Okay? Rewrite the expression given to you in terms of f of x equals something, and you could use the aid of a diagram, the arrow diagram, to get to know what to do. Okay? And the rest follow suit up to the answer. Now, that being said, let's go to question number 3. Remember, feel free to ask questions. Blessing in here, I can see you. Ademola, I can see you. Welcome. Virtue, I can see you. Alfred, I can see you. Olga Mary Grace, thank you. My darling, thank you for being there. Thank you very much. So I can see some of you. Welcome, welcome, welcome. Please, as soon as you enter the class, do this channel a favor by smashing a like on the video. Okay, so smash a like on the video. Let's go to question number 3. I want us to go to question number 3. So let's see. Let's go back to question number 3 now. Now, for question number 3, we have the question. Question 3 says, determine the domain D of the mapping. Determine the domain D of the mapping f x into 2x squared minus 1. Okay, this is the mapping. Determine the domain of the mapping G. This is G. X into 2x squared minus 1. If R equals 1, 7, 17 is the range. And G is defined on D. So this is the question, guys. So how do we solve this question? This particular question also requires that we obtain the domain. Okay? So question 2 was all about obtaining the domain, and question 3 is also all about obtaining the domain. So how do we obtain the domain, guys? Solution. So I'm going to start with writing out my solution. Okay? So what am I going to do next? I'm going to do this. I will start with writing out, like I've told you earlier on, I'm going to write out this function gx into 2x squared minus 1. I'm going to write out this function as g of x equals 2x squared minus 1. So you can call this your step 1. Okay? You can actually call this your step 1. Now, after doing this as your step 1, now looking at the range, if you have an arrow diagram, again, it is not compulsory in solving this question that you must use an arrow diagram. But I tell you, using an arrow diagram would make it easier for you to understand what you are doing. Okay? So that's why I'm using an arrow diagram. So I'm going to call this D, the domain D, because we've been told. So I'm going to call my domain D, and I'm going to call this a set, say C. I'm going to call it C. Now, why am I calling it C? The range R is a subset of the codomain. So if D represents the domain, let C represent the codomain, and I'm going to put the map in here, G. Now, we were told what the elements of the range are. We were told that there is 1 in the range, so 1 is an image. Remember, your range is the set of all images. So if 1, 7, and 17 are members of your range, it means that 1, 17, and 7 are images. So I'm going to put 1, 7, and 17 here. Okay? Now, the question is, if there are elements x1, x2, and x3, we want to know what x1, x2, and x3 are. We want to know what they are. So, looking at this, please take note. You will notice that this one here can be written as g of x1. Okay? Because most likely x1 must have given rise to this image 1 through the function g. Also, through this function g, x2 will generate g of x2, that it will generate 7. And this. Likewise, x3 through the function g will generate g of x3 as 17. So that's what I'm going to do to enable me to understand what I'm doing. Once I have done that, I would now come over to proceed as follows. I'm going to come over to proceed as follows. So what am I going to do next, guys? What am I going to do next? The next thing I'm going to do, if you can see what I'm saying clearly, is to come over here and then write out, start with g of x1. Now, g of x1, if g of x, we are told is 2x squared minus 1, then g of x1 should be 2x1 squared minus 1. Okay? Now, but I have just obtained that, I've just discovered that g of x1 is actually 1. So in place of g of x1, I'm going to put 1. So if g of x1 is equal to 2x1 squared minus 1, it means that 2x1 squared minus 1 is equal to 1. So I would simplify further. 2x1 squared will be equal to, when I take this minus 1 off here to this other side, it becomes 1 plus 1, meaning that 2x1 squared is equal to 2. Okay? Now, x1 squared will be equal to 2 over 2, and 2 over 2 gives 1. So x1 squared is equal to 1. So what is x1? x1 will be the plus or minus the square root, plus or minus the square root of 1, and that will give me plus or minus 1. Okay? So plus or minus 1 will be my x1. Now, once I have obtained that, I would go over to g of x2. So likewise, g of x2 must have given rise to 2x2 squared minus 1. And once that is done, endurance, welcome to the class. Welcome, I can see you. So once this is done, all you have to do is to recall what g of x2 is. So what is g of x2? G of x2 is 7. So I'm going to put here 7 is equal to 2x2 squared minus 1. So 2x2 squared will be equal to 7 plus 1, which is equal to 8. Okay? So when I make 2x2 squared the subject of formula, that's what I'm going to have. Now, if I divide through by 2, I will end up having 8 over 2, which is equal to 4. So what will my x2 be? Let's come over here to continue the problem. x2 squared will be equal to 4, and that implies that x2 will be equal to plus or minus the square root of 4, implying that our result will be, the square root of 4 is 2, so my result will be plus or minus 2. Then finally, I can come over here to the last problem and put here g of x3. So similarly, g of x3 must have come from this, g of x3 squared minus 1. So what is g of x3, guys? G of x3, we were told, is 17. So I'm going to put 17 here. 17 will be equal to 2x3 squared minus 1. And once you do that, it means you can now say 2x3 squared, when made the subject of formula, will give you 17 plus 1. And what is 17 plus 1, guys? It is 18. So 18 divided by 2 is what you would have for x3 squared. And 18 divided by 2 gives you 9. Meaning that x3 squared is equal to 9. and x3 will now be plus or minus the square root of 9. So plus or minus the square root of 9, guys, will give you plus or minus 3. Okay? So what have we been able to achieve? You will notice that doing this routine has given us our domain. So what now can you say is the domain of that function g? The domain contains plus or minus 1, plus or minus 2, right? And finally, plus or minus 3. So this will be the domain of the function. So take note, it is easy to get the domain of the function. Now take note, if you are smart enough, you can overcome or overlook some of these steps in solving your problem in an exam condition. But I like being detailed. You can actually follow this procedure. Okay? Now, if there is no question, so this, we had this to be x squared, x2 squared was 8 over 2, right? Equals 4. Okay. So we had it to be, that was x2 squared was equal to 4. And the square root x2 was the square root of 4. Okay? x2 was the square root of plus or minus the square root of 4, which gave the plus or minus the square root of 2. So, okay? Now, please feel free to ask your questions. I'm expecting you to ask questions. If you do have questions, please ask. That being said, let us go to question number 4. So I'm going to use here, I'm going to be using this to go to question number 4. So I'm going to let that stay a while. Let me leave this d equals plus or minus 1, plus or minus 2, and plus or minus 3. Okay? Let's go to question number 4. So for question number 4, I have a question here. Question number 4 says, f from x to 2x plus 3 is a mapping. Okay? Defined. I hope you can see this. Defined on the set R of real numbers. So the question says determine the pre-images. Determine the pre-images of A 1, B minus 1, C 7, and D minus 5. So please take note. Let me read the question out loud, just in case you can't, you didn't get me earlier clearly. So f of x equals 2x plus 3, we are told is a mapping defined on the set R of real numbers. Okay? Now the question says determine the pre-images of A 1, B minus 1, C 7, and D minus 5. Now, let us start with interpreting the problem. The question, guys, is this. What does this question really want? They want you, in other words, this question is telling you that 1, minus 1, 7, and minus 5 are members of what you can call the domain. Okay? So the domain is actually R, the set of all real numbers, but out of this domain, they are taking out 1, minus 1, 7, and minus 5. Meaning that using your arrow diagram, what you can have is, if you call the domain D, such that D is a subset, if D is a subset of R, the set of real numbers, then you can call D your domain that contains 1, minus 1, 7, and minus 5. Now, they want you to obtain the images. So let's call this set E that contains the images. Okay? Now, they want to know what this will be, what the next one will be, what the next image will be, and what the next image will be. So there are 4 question marks there. So what are we going to do, guys? We are going to do the following. So I'm going to wipe this off, and let's do the following. Let's do the following quickly without waste of time. So to To solve this problem, all we have to do is to use the function we've been given. We are going to use the function we've been given. So what is the function? I'm going to start with writing out the function. The function is f of x equals 2x plus 3. So I've always told you, please write it in this manner. Now, there is in the domain x1. So I'm going to call this, if you can see this clearly, I'm going to call this, I hope you can see this. So I'm going to call this x1, I'm going to call this x2, I'm going to call this x3, and I'm going to call this x4. So when you have x1, it means what you are supposed to have here is 2x1. You would have f of x1 is equal to 2x1 plus 3. So this first one is f of x1, and we want to obtain it. We don't know what f of x1 is. We don't know what f of x2 is. We don't know what f of x3 is. We don't know what f of x4 is. And these are the pre-images they want you to obtain. So we are going to start with f of x1 equals 2x1 plus 3. So what is f of x1? F of x1 is you putting the value of x1. The value of x1, guys, is 1. So the value of x1 is 1. I'm going to put 2 times 1 plus 3. And this will give me 2 times 1 is 2. 2 plus 3 is 5. So I have obtained f of x1. I'm going to go to f of x2. F of x2 should come from 2x2 plus 3. And that means you will end up having 2 times x2. Your x2 is minus 1. So I'm going to put in place of x2 minus 1 and then add 3. So 2 times minus 1 is minus 2. Okay? So this is minus 2 plus 3. And minus 2 plus 3 will give you 1. Okay? So we've now obtained f of x2. You will then go over to f of x3. F of x3 is 2x3 plus 3. Meaning that f of x3 should give 2 times what x3 is. And x3, guys, is 7. I hope you can see this. So x3 is 7. So putting 7 here plus 3, what would it give us? 2 times 7 is 14. 14 plus 3 would give you 17. So it means that our f of x3 is 17. Finally, guys, f of x4 will be 2x4 plus 3. And what is f of x4? It will now be 2 times what x4 is. And x4 is minus 5. So 2 times minus 5 plus 3 is what will emerge here. And 2 times minus 5 is minus 10. So I'm going to put minus 10 here plus 3. Minus 10 plus 3 is minus 7. So the result here will be minus 7. So in all, we have obtained our range. So what are we going to do? You can now say, therefore, the range R, if R is your range, so I'm going to write range will be equal to, my first element in the range is 5. I'm going to put it here. My second element is 1. I'm going to put it here. My third element in the my third image will be 17. I'm going to put it here. And finally, the last one is minus 7. So that answers that question. So that answers the question. So let me see. Okay, so far so good. No questions. Thank you very much. I like the fact that you are paying attention to what is being done. So let's go over to question number, that was question number 4, am I right? So let's go over to question number 5. Let's go over to question number 5. Remember, I promised you tonight, having done everything we need to do, or most things we need to know about functions of a real variable, I had told you earlier on that tonight will be all about solving problems. So let's go to question number 5. So I'm going to write down question number 5. If g from x to x plus 1 over x plus 2 is a mapping, okay, is a mapping defined on the set of real numbers excluding minus 2, find A, G of 1, B, find G of 1 over 2, C, find G of minus 3, D, find G of 0, E, find G of minus 1, F, find G of 4, H, find G of 2, and finally, so that's A, B, C, D, E, F, this should be G, and then finally H. So in H, we have to find G of 3. Now, please take note, guys. I'm going to get, in this class, I'm going to solve this. That is A, I'm going to solve B, and I'm going to solve C. That should be enough to show you how to do the rest, okay? I'm going to leave the rest for you to get done, and please, when you do them, kindly reach out to me through the comment section or through the email, okay? Through my email on my YouTube channel, you can reach out to me showing me what you've done. But please, I'm going to do this, and this. That is A, B, and C. So how do we solve this problem? Let's read the problem all over again. It says that if G of x equals x plus 1 over x plus 2 is a mapping defined on the set of real numbers excluding minus 2, then find this. So it is that simple. All you have to do, guys, is this. All you have to do is a simple routine. If you are given this problem in the exam or your assessment, don't panic. Again, I say, don't panic. It's a simple problem. All you have to do is to have an understanding of what you are requested to do. So I'm going to put here solution. I'm going to put solution and then come over to A. In A, we are asked to find G of 1. So I'm going to put a question mark here. G of 1 is what? So what is G of 1? Now I'm going to come over here and recall that we've been told G of x, that is G of anything, is x plus 1 over x plus 2. So when x is 1, I'm going to have G of 1. All you have to do when x is 1 is to replace 1 with x, or replace x with 1 wherever you find x. So in place of this x, I'm going to put 1, so that would amount to 1 plus 1. And in the denominator, I'm going to have 1 plus 2. So what I'll end up having as G of 1 is 1 plus 1, which is 2, all over 1 plus 2, which is 3, and that solves the problem. So you can see it is that simple. So B, let's go back to B. B says obtain G of 1 over 2. G of 1 over 2 can be obtained similarly by putting 1 in place of x there, 1 over 2 in place of x plus 1, all over 1 over 2 in place of x plus 2. So 1 over 2 plus 1 will give you 1.5. All over 2 plus half will give you 2.5. Now, you can simplify further. 1.5 is 3 over 2, right? And divided by 2.5 is 5 over 2. So, if you do the mathematics, 3 over 2 divided by 5 over 2 is the same as 3 over 2 times 2 over 5. And that means 2 cancels 2, and your result will be 3 over 5. So, what is G of half? Based on that function given to you, G of half is 3 over 5. So, what is the idea for solving this problem, guys? The idea for solving this kind of problem is simply to replace what x is into the function. So, if you replace x with what it is given to you at any instance into the function, you will simplify to get your result. So it is that simple. Now, let's go to the last one, C, I had said I will do. So please, guys, I am leaving you to get G of 0. I am leaving you to get G of minus 1. I'm leaving G of 4 to you, G of 2 to you, G of 3 to you. Please solve them and get back to me in the comment section or through the email in my YouTube channel, okay? So let's get the final one done before we go over to question 6. So G of minus 3. What is G of minus 3? It will be minus 3, which is your x, plus 1 all over minus 3, which is your x, plus 2. Now, minus 3 plus 1 will give you minus 2. And minus 3 plus 2 will give you minus 1. The minus cancels minus, and you end up having 2 over 1. And guys, what is 2 over 1? Anything over 1 is that stuff. So you end up having 2 as your result. Okay? Now, please, you could actually go back to the video from the beginning when we are done with the class to go through everything in slow mode or slow motion so as to understand what was done carefully, okay? But in case you have any question while the class is going on, you can ask your question. So let's go over to problem 6. Let's go over to problem 6. Question number 6. I told you we have a lot of problems. There are so many problems to solve, and I'm starting with the very simple ones. Gradually, we will go into more complex problems, but let's see problem number 6. So let's go back to problem number 6. So what does problem number 6 say? Problem number 6 says, given that h x into x squared plus 2x minus 3 is a mapping, okay, defined on the set A equals minus 1, 0, 1, 2. Find the range of h. So this is problem number 6, okay? So you are asked to find the range given the function h of x equals x squared plus 2x minus 3. So let's solve that problem. All you would have to do in this case is simple. You will start with writing h of x equals x squared plus 2x minus 3. So you are told that the mapping is defined on the set A. What it means for the mapping to be defined on the set A is that you've been provided your domain. Your domain is A. So if your domain is A, it means they want you to find, it means if A is equal to minus 1, 0, 1, and 2, you can simply write it as x1, where x1 is your minus 1. Okay? You can write comma x2, where x2 is your 0. You can write comma x3, where x3 is your 1. And you can write comma x4, where x4 is your 2. Okay? Now, it means you have to find h of x1. What is h of x1? It will be x1 squared plus 2x1 minus 3. It will follow the same pattern of the function. So, what would that give us? What is x1, guys? It is 1, minus 1. So, I'm going to put here minus 1 squared plus 2 times minus 1 minus 3 and simplify. So, when you simplify this, minus 1 squared will give you 1 plus 2 times minus 1 will give you minus 2. So this becomes minus 2. Then you bring your constant minus 3. This will result in 1 minus 5. And 1 minus 5, guys, will give you minus 4. That means h of x1 is minus 4. Now I will go over to h of x2. h of x2 will be x2 squared plus 2x2 minus 3. And when you get this done, the next thing you now do is to put in place of x2 whatsoever x2 is. And we are told that x2 is 0. So this will be 0 squared minus 2 times 0 minus 3. Now, everything 0 squared is taken to be 0. Minus 2 times 0 will be taken to be 0. So you will be left with an answer minus 3. So h of x2 is minus 3. Then you come over to h of x3. I hope they can see this. So h of x3 will be x3 squared plus 2x3 minus 3 equals what? x3 squared will be whatsoever x3 is, in this case 1 squared, plus 2 times what x3 is, which is 1, minus 3. So 1 squared is 1, plus 2 times 1, which is 2. 1 plus 2 will give you 3. 3 minus 3 will give you 0. And we have obtained h of x3. Finally, when you obtain h of x4 will be x4 squared plus 2 times x4 minus 3. And that will be whatsoever x4 is, all squared, which is 2 squared because x4 is 2, plus 2 times 2 minus 3. So 2 squared is 4, 2 times 2 is 4. So 2 squared, which is 4, plus 2 times 2, which is 4, will give you 8. 8 minus 3 will give you 5. So that being said, you can now write out your range. If your range is R, all you have to do, your range will contain h1 of x, or rather h of x1, comma, h of x2, comma, h of x3, comma, h of x4. So what did you get as all these results? H of x1 gave us minus 4. I'm going to put it there. H of x2 gave us minus 3. H of x3 gave us 0. And h of x4 gave us 5. So this is what they want you to do. And that answers that question. So, okay. So, let's move over to the next question. The next question is question 7. Let's go back to question 7, guys. So let's go back to question 7. So what are we asked to do in question 7? I'm going to be putting up that question on the board. I'm going to be putting it up on the board. So please endeavor to solve the problem I gave you earlier to solve and get back to me in the comment section or through the email in my YouTube channel. Okay, my email. So let's go to question number 7. Let's go to question number 7. So, for question number 7, you have given that f(x) into a x squared plus hx is a mapping on the set of real numbers. On the set of real numbers. Given that f of 1 is equal to 5 and f of minus 1 is equal to minus 1, determine the values of A and B. I love this problem. I love this kind of problem. Okay? So, let's see how to solve this problem. What will be the idea? Let's read out the problem again before we begin. So, in today's class, we are going to be solving up to question 10. The last problem I have here is question 10. In tomorrow's class, we will continue with solving problems, and that's why I called it in the thumbnail. You'll see the thumbnail carries Q&A series part 1. Okay? So in tomorrow's class will be Q&A series part 2. Okay? Now, let's see. If you are given this kind of problem, all you have to do is to write it out. F of x is ax squared plus bx. That's the first step I'm going to take. Now, once I write this out, the next thing I'm going to do, this particular problem will lead to a simultaneous equation. Because without this simultaneous equation developed, you won't be able to get the values of A and B. So, how would you get the simultaneous equation? You will follow this pattern for f of 1. You are told that f of 1 is equal to 5. Okay? And f of minus 1 is equal to minus 1. So what are you going to do? You are going to use this relationship to obtain an expression for f of 1. So I'm going to write here, but f of 1 is equal to a times what x is, in this case 1 squared, plus b times what x is, in this case 1. And that would amount to a times 1 squared. 1 squared is 1, so 1 times a will give us a. B times 1 will give us b. So this will be a plus b. Okay? I will now say therefore a plus b, since f of 1 is equal to 5, a plus b will be equal to 5. And I'm going to call this equation 1. That's the first step I'm going to take. The next thing I'm going to do will be to repeat the procedure this time around for f of minus 1. So I'm told that f of minus 1 is equal to minus 1, but for a start, I'm going to obtain f of minus 1 using this relationship. So it will be a into bracket minus 1 squared plus b into bracket minus 1. And that would mean having a into bracket minus 1 all squared is 1. So 1 times a will give you a, but b times minus 1 will give minus b. And this implies, I would say, therefore, a minus b will be equal to minus 1. So I will call this equation 2. Now, once you have obtained equation 2, let's come over here. You will now say solving equations 1 and 2 simultaneously. Solving equations 1 and 2 simultaneously gives, I will now bring this, a plus b equals 5, my equation 1, and a minus b equals minus 1, my equation 2. So you can still bring this equation 1, equation 2 over here. Okay? So this is what I'm going to do. Since clearly my coefficients are balanced, I'm going to apply elimination method. I'm going to be eliminating a, okay, or eliminating b. How am I going to eliminate b? I'm going to say add 1, equation 1 to equation 2. If I add equation 1 to equation 2, b will be eliminated. So a plus a will give me 2a if I follow this, and b plus minus b will give me 0. So 2a plus 0 will give me 5 plus minus 1, and 5 plus minus 1 is 4. Okay? So that will now mean 2a is equal to 4 and a will be equal to 2. Now, once you obtain the value of a to be 2, you will now go further to say substitute for a equals 2 in, say, equation 1. So I'm going to substitute for a equals 2 in equation 1, and when I do, I'm going to have a, which is 2, plus b equals 5. And if a plus b equals 5, it means b will be equal to 5 minus 2, which is 3. So that is how to solve that problem. It is that simple. So at the end of this problem, what have we obtained a and b to be? We have obtained a and b to be 2 and 3 respectively. And the idea is simple for solving that problem. Let's go to problem number 8. Let's go to problem number 8. Okay, so Mary Ben, I can see you. Welcome to the class. Please, guys, if you are all watching this video, kindly do me the greatest favor by liking the video immediately. Like the video immediately. Thank you very much. I really appreciate your presence on the channel. God bless you. Endeavor to share the videos after now, and endeavor to also watch it all over again if you don't understand anything we've done so far or some of the things we've done so far. Now, let's quickly go to question number 8. Question number 8. So let's go back to question number 8. So what does question number 8 say? Question number 8 says the zeros, what is called the zeros, or what are called the zeros rather, the zeros of a function. This particular problem starts with defining what is called the zeros of a function to you guys. And that's why I like this problem. So some of you, just in case you don't understand what the zeros of a function is, probably in first semester you must have done algebra and trigonometry, otherwise maybe in your school called general mathematics 1. You must have treated polynomials. You must have treated polynomials. Okay? You must have treated polynomials. So if you've treated polynomials, you must have come across something called the zeros of a function. You must have come across something called the zeros of a function. So now this problem starts with asking or defining the zeros of a function. Are we good? So So what is the zero of a function? Let's write. Now the zeros of a function are the zeros of a function are the elements of a domain, whose images are equal to 0. I'm going to explain what this means, but after defining this, after the problem defines this, it now so let's highlight this. I'm going to highlight this. So take note of that as that definition. So what is called, let's assume, let me explain this quickly before I write out the problem. So let's assume we have a function y equals f of x. What this means, by saying the zeros of a function are the elements of a domain whose images are equal to 0, it means the zeros of a function can be obtained when you equate f of x to 0 and simplify. Okay? So if you want to obtain the zeros of a function, equate the function to 0 and solve for the value of x, or solve for the value of the independent variable. It's as simple as that. So that being said, what then is the problem? It says determine, the problem says, problem 8 says, determine the zeros of the functions defined by, determine the zeros of a function defined by f of x equals 2x minus 3, b, h of x equals x squared minus x, and c, g of x equals x squared plus x minus 6. Okay? Now, so let's use this idea. If to obtain the zeros of a function, all you have to do is to equate that function to 0 and simplify, or find the value of x, the independent variable. The starting problem, if we are to obtain the zero of the function a, f of x equals 2x minus 3. How do you obtain the zero of this function? All you have to do is to equate f of x, that is 2x minus 3, to 0 and solve for x. So 2x is equal to 3 when 3 comes over to this other side, and x will be equal to 3 over 2 when you make it the subject of formula. This value, x equals 3 over 2, is called the zero of this function. It is as simple as that. So guys, to obtain the zero of a function, equate the function to 0 and solve for the value of the independent variable. It is as simple as that. So what did I do here? In problem A, I equated f of x to 2. F of x, we were told, is 2x minus 3. So I equated 2x minus 3 to 0 and then solve for x. So it gave me that result, 3 over 2. Now let's go to problem B. Problem B requires us to find the zero of this function, x squared minus x. How do we obtain the zero again? The zero of h of x equals x squared minus x is obtained when you equate x squared minus x to 0. Okay? If you equate x squared minus x to 0, now I wouldn't want you to make a mistake. This problem is quadratic. So don't fall into the trap of solving this problem. Some of you may get excited and solve this problem in this manner. Some of you would go about it doing this, equating x squared to x by taking x to the other side and then dividing through by x to get x equals x over x squared. Okay, that's dividing through by x squared rather, or dividing through by x probably. You could even divide through by x, and this will be x, implying that you end up having x equals 1. Please, if you do this, you will be wrong. Okay? The reason why you will be wrong is that the solutions to a quadratic, there are always two solutions to a quadratic equation. So if you go about it this way, you would have lost one of the solutions. So what then should you do? What you have to do in this instance is to factorize. So if you factorize, x comes out and this will be x minus 1 equals 0. And if the product of two numbers is equal to 0, it is either A, the first number is equal to 0, or B is equal to 0. So if x times x minus 1 is equal to 0, then it means either x is equal to 0 is a solution, or x minus 1 is equal to 0 is another solution, implying that x is equal to 1 and x is equal to 0 are the solutions to this problem. So this problem is quadratic and should have two roots, one of them being x equals 0 and the other one being x equals 1. So what are the zeros of h of x? They are 0 and 1. How did we obtain them? All we had to do was to equate the function h of x to 0 and solve the problem in quadratic manner to obtain x equals 0 as a root and x equals 1 as another root. So x equals 0 and x equals 1 are the zeros of h of x. Now, finally, for this particular problem, let us obtain the zeros of c. So I'm going to bring this over here. Let me bring this last problem under question 8 over here. So let me bring it over here. Okay, so the last problem, g of x, that is problem C, g of x is equal to x squared plus x minus 6. So what will be the zero of this function? The zero of this function occurs when g of x is equal to 0. And when g of x is equal to 0, it implies that x squared plus x minus 6 will be equal to 0. Please, if you are solving this under exam condition, I would advise you use the quadratic formula. So, using the quadratic formula, please, just in case you don't know about the quadratic formula, you can check my shorts on quadratic formula or my videos on quadratic formula in my channel. So go to my channel, it will show you how to use the quadratic formula, okay? There is a video I made on quadratic formula, you can check that out after this class, it will help you. So, using the quadratic formula, x is equal to minus b plus or minus square root of b squared minus 4ac all over 2a. And this comes from ax squared plus bx plus c equals 0. So a is the coefficient of x squared, b is the coefficient of x, and c is the constant term in the quadratic equation. So what I'm going to do will be to use this idea of the quadratic formula to solve this. Clearly, you will see that the coefficient of x squared is 1, the coefficient of x is 1, and my constant term is minus 6, since I can actually write this as plus minus 6. Okay? Now, it means that my a is 1, my b is 1, and my c is minus 6. That implies that the zeros of x will be minus b, that is minus 1 plus or minus square root of what b is, which is 1 all squared, minus 4 times what a is, 1, times c, which is minus 6, all over 2 times a, which is 1. And this will simplify to minus 1 plus or minus square root of 1 squared, which is 1. Minus times minus is plus, so this gives 24. 6 times 4 all over 2. 2 times 1 is 2. So if you solve further, you will end up having that x is equal to minus 1 plus or minus the square root of 25 all over 2. And this will reduce to 1 plus 5 over 2, or minus 1 minus 5 over 2. Okay? And if you go further to finalize the problem, what then will be the zeros of the function? The zeros of the function will therefore be, you simplifying, minus 1 plus 5 gives you, minus 1 plus 5 will give you 4, so you end up having 4 over 2, or minus 1 minus 5 will give you minus 6, so you have minus 6 over 2. So this will end up being 2 or minus 3. So those are the zeros of that function. So to obtain the zeros of the function, equate the function to 0 and then solve for the value of the independent variable. Okay? That's what you should do. So if you come across this in your exam or you come across it in an assessment, it is simple. Don't panic. just watch the video all over again, just in case you don't understand, or implement what we have taught and you will get your result. Okay, so let's go to question 9. We are edging closer and closer to the end of today's question and answer series on functions. So let's go over to question, I think this should be question 9. So let's go over to question 9. Remember, our question and answer series today will be stopping at question 9. Now please do well to attend tomorrow's question and answer series on functions, because it just might be our last series for now. After tomorrow's class, before we get into another series, question and answer series, I would love us to go into differentiation. So if we take our Q&A series part 2 on functions tomorrow, it means the next class that follows will be on differentiation. And we will be taking intermittently, we'll be taking our question and answer series on functions. We'll be moving forward and backward in that manner, okay? So we'll be going over to the Q&A series on functions. In tomorrow's questions, I would like us to look at problems on composite functions, problems on inverse functions. Those are very serious problems you might be asked in your exam. And it is very important you attend tomorrow's class. Please, do me a favor to bring your friends to this channel, bring them to this live class. They stand to gain a lot. And endeavor to smash a like on the video. Tell your friends to subscribe to the channel. They stand to gain a lot if they do, and they stand to miss a lot if they don't. Okay? So do that for us, do that for the channel, and get them to subscribe, turn on their notification button, and it will do a lot good to the channel. Thank you very much. So let's go to question 9. Now, in question 9, we are told let x be equal to a, b, c, and d, and y be equal to p, q, r, and s. And g, a function, let there be a function g that takes elements from x and assigns them elements from y to become images. So let that be a mapping defined by the diagram. The diagram below. This that goes from x to y, f, okay? And this is a, b, c, and d. This is p, q, r, and s. The question says find the image. Find the image of, or find the range rather, find the range of f. That's what the problem demands. Find the range of f. So how do we find the range of f, guys? The solution is as follows. How do we find the range of f? So what we are told, let me put out the diagram. The diagram goes this way. A goes to S, D also goes to S, C goes to Q, and B also goes to Q. So the range, this problem is very simple. The problem is very simple. So A goes to S, D goes to S, C goes to Q, and B goes to Q. Now, remember, the range of a function is the set of all images. Is this function, this relation a function? It is. Yes, it is. Because it is a function because all the elements in the domain are have images. Okay? A has an image S, D has an image S. Now, B has an image Q, C has an image Q. More than two elements, more than one element in the domain can have one image. But one element cannot have more than one image. So it is a function. Okay? So looking at this particular mapping, what is the range? All you have to do is, if you say let R be the range of f. If R is the range of f, then it means that R should contain all the images of this mapping. Now, what are the images? The images are just Q and S, and that answers the question. So the image of the mapping is the set that contains, and the range of the mapping is the set that contains all the images under that mapping. And the images are those elements of the codomain that were assigned to elements in the domain uniquely. So what are the elements assigned to the elements in domain uniquely? They are Q and S, irrespective of repetition. Now, one of you might ask the question, sir, why is A? Why are you not writing A? That is, why are you not writing the range as what do you call it? S, S, Q, Q. Whether you write it as this or the first, they are the same. So we don't count repetitions in sets. Okay? We don't count repetitions in sets. So this set is the same as that set. They are equal. Okay? Now, let's go over to, that solves that problem. You can see the problem is that simple. Let's go over to question 10, being our last question for tonight. Let's go over to question 10. Thank you so much for staying tuned to this point. Up to this point, thank you for your patience, thank you for your understanding, thank you for your patronage. I really, really appreciate your patronage, okay? So please get your colleagues to come onto the channel, participate in the class. It promises to be very interesting. Problem solving is what we are doing now on functions of a real variable. Please like, share, and subscribe. Also drop your good comments, especially the comments pertaining to the problems I gave you to solve. I want to see you guys solve them and send me results in the comment section. I also would want to see them in my email, so you can send them there, but preferably I would love to see them in the comment section. So do well to subscribe to the channel and drop your comments in the comment section. So let's go to question 10, being our final problem for tonight. So question 10 says, let x be equal to minus 303 and y be equal to 1 and 10. Okay, so the diagram shown below, in the figure, or the diagram shown below, illustrates a mapping from the set X into the set Y. Okay? So all you have to do is this. Watch out for the diagram they've given to you. This is the diagram. In this diagram there is minus 3, 0, and 3. In this diagram there is 1 and 10. And you have this, and this. So this is what is given. So the question now comes in this manner. It says, determine the rule of the mapping. Determine the rule of the mapping. That's question number 1. Another question says, is the mapping 1 to 1? Another question says, is it onto? And the last question now says, what is the range? What is the range of the mapping? What is the range of the mapping? Okay? So, let's now end our class tonight with this particular problem. So the problem says, let x be equal to this and y be equal to that. The diagram shown below illustrates a mapping from the set X into the set Y. So this is the set X and this is the mapping, taking elements from the set X and assigning to them unique elements from the set Y. So the question now says, there are so many questions here. So the first question says, determine the rule of the mapping. So what is the rule of the mapping? So the second question says, is the mapping 1 to 1? The third one says, is it onto? And the fourth one says, what is the range of the mapping? So, solution. Let's start with question number 1. How do we determine the rule? If you remember vividly what I told you in my class, probably the 5th or the 4th or the 3rd class, I showed you how to determine the rule. So let's see what the rule is. The rule is what links the function with elements in the domain and codomain. So why is minus 3 producing 10? Now, a quick observation, if the function is f, it means it is f of an element x here that gives an element here. So let us say f of x gives y, or you could write it as y equals f of x. Now, you will notice that y1, if we call this x1, call this x2, call this x3, you will notice that corresponding to them are y1 and y2. Okay? Now, y1 comes from f of x1. Notice again that y1 comes from f of x2, and y2 comes from in two ways. It comes from f of x1 and what? F of x3. Now, if you observe carefully, how does minus 3 amount to 10? You will notice that the function that is being in operation here is that which takes the square of x and adds 1 to it. Okay? Now, if you look at how does y1 link up with x2? What was x2? It was 0 squared. 0 squared plus 1 gave 1, or gives 1. Now, in this case, you will notice that y2 came from f of x1, or gave rise to f of x1, or y2 came from f of x1. Now, what is x1? Minus 3 squared plus 1. It gives you 10. Okay? And this also is 3 squared plus 1, which gives you 10. So, the rule here of this mapping is that for you to get an element in the codomain, you have to square any element in the domain and add 1 to your result. So, squaring an element in the domain and adding 1 to the result of squaring an element in the domain will give you an element in the codomain. That's the reason why minus 3 squared plus 1 is giving you 10, and 3 squared plus 1, which is 9 also plus 1, is giving you 10. That's the reason why 0 squared, which is 0 plus 1, is giving you 1. So the rule there that answers the first question under that question 10 determine the rule of the mapping. The rule of the mapping is y equals f of x is equal to x squared plus 1. Now, let's go to II, the next question. The next question now says or demands to know if the mapping is 1-to-1. Guys, is this mapping 1-to-1? Clearly, the mapping is not. This mapping is not 1-to-1. For a mapping to be 1-to-1, no element of the domain must share an image. But you will notice that minus 3 and 3 are sharing an image, 10. Remember, we gave a mathematical definition to a 1-to-1 mapping yesterday, that if there are two elements that are equal, then their result should give you the same image. But if the two elements are different, they shouldn't produce the same image. Now, you will notice that the two elements are different. Minus 3 is not the same as 3. However, they are producing the same image, 10. So, since minus 3 and 3 are not the same, but producing the same image, it means that this mapping is not 1-to-1. Mappings that are called 1-to-1 mappings do not share images. So, simply put, since f of x, that was since y equals 10 is an image, of is an f image of minus 3 and 3, the mapping f is not 1-to-1. So in a 1-to-1 mapping, no element of the domain share an image. Okay? So that being said, let us go to III, the third question. What were you asked? Now that we know that that mapping is not 1-to-1, the question is the mapping, however, onto is the mapping onto. When is a mapping onto, guys? Please go over my video of yesterday. A mapping is onto if every element in the codomain is an image. You will notice that this mapping is onto. This mapping is onto. Why is this mapping onto? Every element, what are the elements in the codomain? There are two elements in the codomain, 1 and 10. And you will notice that those two elements are images. Once every element in the codomain is an image, that mapping is an onto mapping. Okay? So an onto mapping is a mapping. It is not a relation, it is a mapping. Meaning that before it even gets to being onto, it must first of all be a mapping. In other words, it must have satisfied the two conditions for being a mapping. And in addition to satisfying those two conditions, every element in the codomain must be an image. So this mapping is onto. So what am I going to write? F is onto since 1 and 10. 1 and 10 that are members of Y are images of -3, 0, and 3 that are members of X. So since all the elements in the codomain are images, that mapping is an onto mapping. Then finally, guys, the last question under question 10 says, what is the range of the mapping? The range of any mapping is the set that contains all the images. So all you have to do here is to say, let R be the range of F, be the range of the mapping F. Then, or therefore, R will be a set that contains what and what. Clearly, you will notice that if R is the range of the mapping, it will contain all the images of that mapping, and the images are clearly 1 and 10. So all you have to do is write here 1 and 10, and that solves the problem. So I hope you had a nice time watching this live class on the Q&A series. I hope this Q&A series was good enough for you. Please, if you found it interesting, smash a like on the video. If you were 10 watching the video or 10 watching in this live class, please endeavor to give me 10 likes, okay? Smash a like on the video. If you haven't subscribed and you were watching the video live, please do the needful now. Kindly do us that great deal of good by smashing a like on the video and endeavoring to subscribe to the channel. And please do well to turn on your notification button, because for some time now, anytime I'm to go live, I would always send the links. Now, the reason for sending the link is because some of us here have not turned on our notification bell. All you have to do so as to get notified whenever we go live or drop a new video is to click that notification bell and put the one. Please, when you click on it, you will end up seeing something like this, a bell like this. The one that has 2 colons on top, or the quotation mark on top, is the one you go for. Okay? When you click on this one, anytime we go live, anytime we drop a new video, you will get a notification. So if you can do that, we won't have to be sending you links all the time. Okay? So when you subscribe to the channel and turn on your notification bell in this manner, it gets you notified on any activity on our channel. Please join the live class tomorrow to watch our Q&A series part 2 on functions of a real variable. Tomorrow promises to be more interesting because we'll be going into problems on composite functions that you might be asked in your exam. We'll be going into problems on inverse functions that you might be asked in your exam, and problems that are more complex than what we've done today. So until tomorrow when I see you, good night and God bless you. Thank you very much.